Uh, in this video, we will discuss more examples on how do we evaluate the duality of some given function. So let's start from the general exponential function, right? So that's in our in the list of elementary functions, but we still don't know how to differentiate that function yet. So y equal to a to x, where a here is positive, right? And we do know something, right, about exponential function. We know one thing. If you have a equal to e, then the duality function, we know this is e to x, right? So we want to make a connection between a to x and e to x and apply the rules we have learned about differentiation and try to figure out the duality of a to x, right? So what's the connection between a to x and e to x? How do we change from a to e, right? If you have a is positive, we know that a here is basically e to natural log of a, right? That's how do we make a connection between a and e, right? Because e and natural log, they cancel each other, right? And so this is equal to e to natural log of a, then to the power x, right? By the exponential laws, right? One of them. So this is same as e to natural log of a times x, where a is constant, right? Now you can see that this is what? This is a composition of two functions. Inner function is natural log of a times x. Outer function is e to x, right? We can apply our chain rule, right? The chain rule is a good rule to handle the composition of two functions. So this is our inner function. Outer function is e to x, right? Okay. Our inner function here, g of x is natural log of a times x. So g prime of x is natural log of a, right? And outer function, and f of x is e to x. So f prime of x is basically e to x, right? So we apply our chain rule y prime, which is same as e to natural log of a times x prime. So this is apply our what's that called? Chain rule directly. You get e to g of x, which is natural log of a times x, right? That's our first factor, times g prime. So this is natural log of a, right? The first factor is nothing but a to x times natural log of a. So we get our formula for this a general exponential function, right? Which is a to x prime is a to x times natural log of a, right? So this is one more formula we have on how do we differentiate general exponential function, right? Okay, now let's see more examples, right, on how do we differentiate functions using all the rules we have so far, right? Let's see examples. All the rules we have so far, right? The first one here is f of x is 1 over 1 plus tangent x to the power 3, right? So let's try to differentiate that function using the rule differentiate of x, right? So now you can see that this is the quotient. We can apply quotient rule, or you can change the function to a simpler form. So this is same as 1 plus tangent of x to the power -3, right? So this is basically a composition of two functions. Inner function is 1 plus tangent of x. Outer function is x to -3, right? So let's try to write down the answer directly, right? F prime x, which is the derivative of the outer function. So if the outer function is a power function to the power -3, apply a power rule, we bring down -3. So this is -3. The inner function, which is 1 plus tangent of x to the power, so power -1, which is -4, right? Inner function is still inner function, times the derivative of inner function, which is 0 plus secant square of x, right? So this is basically how do we differentiate this function 1 plus tangent of x to -4 times secant square of x, right? Okay. Now let's see one more example, right? One more example here is 2. Our function is y equal to sine of x. I can see that this is a composition of 3 functions, 3 sine functions, right? You have a inner function, another inner function, outer function, right? So you can apply chain rule like in 2 steps, right? First, consider this to be your inner function. This is our outer function. Then when you try to differentiate this inner function, apply chain rule one more time, right? Just apply chain rule twice. First outer function is the outest function. You can call that sine, right? So y prime is the outer function, is cosine. Keep all the inner functions, which is sine of x. When you apply chain rule, you need to times inner function prime, which we don't know what's that yet, prime, right? So this is first factor, still keep that, cosine of sine of x, no, sine of x, right? Sine of x times cosine of sine of x, then time due to the inner function, which is cosine of x. So this is how do we differentiate function obtained by taking the composition of 3 times or even 4 times. We can differentiate our function.